Hey, what's up? I'm Dave Boyer, aka Mr. Boyer, aka the Swamp Man, here in my classroom in Kernersville Middle School, and I'm teaching a lesson today about convergent plate boundaries. So before we get to the convergent part of that, we need to understand plate boundaries. It's a pretty easy idea. We've talked about how the crust of the Earth is broken up into several plates. The plates have names based on things like they might be named after an ocean. We've got the Pacific Plate here. They might be named after a continent like the South American Plate. They might be named after a group of people like the Nazca Plate off the coast of South America. Each of the spots where a plate touches another plate is called a plate boundary. And these are the most exciting places on Earth. This is where the Earth's surface is changing in places in time that you could actually see it happening. This will be places where there's the most earthquakes, where there's volcanoes, where mountains are forming, where ocean trenches are. These are just some really neat places. I want to show you two areas that we're going to kind of focus on this lesson about. One of those is the western side of South America, so the South American Plate on one side of it, and where it connects together with the Nazca Plate. We'll come back to that in just a little bit. The other place I want you to take a look at is the Indian Plate and how it is connecting together, interacting with the Eurasian Plate just to its north. So those are two areas we're going to look at. Each of these plates is moving, as we've talked about. So we're going to talk about the movement of the plates also. Let's go ahead and take a look at our lesson objectives for this. Kind of broke it up into three parts. So for convergent plate boundaries, we're going to look at the action that's involved. What are the plates doing? How are they moving? What's causing them to move? And then what's the result of that? So we're going to take notes in our science notebook today. I'm going to go ahead and help you get that set up. So if you turn to your next page that you have available, your paper is going to look something like this. Trying to model it for you. We're going to put a title at the top of the paper. We're going to name this Convergent. And then to help us space out our paper and use the most of it, we're going to draw a line about 1/3 of the way down our paper so that we have a smaller section on the top and a larger section down on the bottom. So again, that's about 1/3 and about 2/3 of your paper. Skip down 6 or 7 lines or so underneath your title, draw a line going across of it so that you've got your top third and your bottom 2/3. I'm going to go ahead and take that off the screen and start on the first section, the top half. So now my board is only going to show you the top third of your paper. You're still going to have that title on the top, Convergent. So before we jump into a lesson about the plates that are involved, we're going to kind of first talk about just the word convergent itself. So words can often be broken down into things like prefixes and root words and suffixes. So this prefix here, con, C-O-N, means to come together. If we can understand that, that can really help us understand the action involved in these plates. If you don't know that prefix con, meaning come together, there's tons of words in the English language that use that same prefix. Maybe a negative kind of connotation could be the conspire. Conspire is when you get together with somebody else, come together with somebody else to plan something, usually illegal. Congregate. Sometimes I'll hear teachers in the halls yelling, "Hey, stop congregating in the hallway." Congregate means to come together, a group of people coming together to talk, probably in the hallway. In science, we might get to a word later when we're studying rocks called conglomerate. A conglomerate rock is a mixture, a bunch of rocks that come together to form a new rock. So prefix con means come together. So the things that are coming together are plates of the crust. So we're going to go ahead and start to separate out some of that. First thing over here on the left side of the screen, we're going to kind of section off something that I'm calling the action. So the action is going to be what is happening with the plates that are involved. So we need to draw in a plate or two. Do these as like 3-dimensional rectangular prisms. We can label are layers of the earth. So that plate is going to represent a plate of the crust. And then that's going to be right next to another plate, because these are plate boundaries, two or more plates that come together in the same spot. So first of all, the action means come together. So we're going to have these plates pushing against each other, coming together, meeting in the middle. Pretty simple idea if we can understand that prefix, I think. Come together, con. So there's our action, two plates coming together. The next thing to go over is going to be the cause. So the cause in any one of these things with plate tectonics is going to be the convection currents that are occurring in the mantle underneath them. The mantle drives the tectonic plates. It pushes them, it pulls them, it moves them around the planet and makes them crash into other plates and interact with other plates. So let's try to draw that in. Again, this is only the top third of your paper, so you should not have gone below that line that we drew in the beginning. The bottom of that section, let's go ahead and label out the core. Of course, we can break the core into the outer core and inner core, but for the purposes of this, we're just going to consider the core as this insanely hot area of the planet. But the core is not equally hot throughout the entire core. So we're going to have areas where we could label it as hotter compared to only hot. And then somewhere over here, another area of the core, we might have hotter temperatures again. And the area that we're really trying to look at is the mantle. So in the mantle, the composition of the mantle is liquid rock. Rock that is so hot it can't exist in a solid state. Well, liquids, being fluids, are free to move around and flow, and thus we get to convection. So in convection, we're going to need the hottest areas to cause the magma to rise towards the surface of the, towards the top of the mantle and the bottom of the crust. So we're going to have arrows coming up above those hotter areas. Well, then fluids want to move from high pressure to low pressure. If we're adding more material, more liquid rock is rising towards the top in this area, that's going to create a lot more pressure, and it's going to have to spread out to relieve that pressure. So we're going to have magma moving away from that hot spot. As it moves away, it's also decreasing its temperature. It's cooling down because it's getting away from the core. As it cools down, it's going to become more dense and sink back down towards the core. At the bottom, it's going to build up pressure again here at the bottom, and it's going to need to relieve that pressure by spreading out along the bottom. So we have these two convection currents side by side. Each convection current is driving a different tectonic plate. But if we see these arrows on the top of the convection current, this arrow is pulling this plate or pushing this plate forward to the left. This one's pushing this plate forward to the right. And the spot that they're coming together is our convergent plate boundary to come together. So I'm going to go ahead and stop the video, and I'll continue it on that bottom 2/3. But if you have any questions, you can send me your questions in the e-learning help center that I have the page on my Power School page, and I'll be happy to try to answer them as quick as I can. So I'll come back at you with the results in just a minute. Just wanted to stop and share that with you and tell you science rocks. Peace.